Dear students, very good morning. Today we are going to discuss about how to solve an LPP using Simplex method with the help of Microsoft Excel. So the problem here is to maximize z equal to 4x1 plus 10x2 subject to the constraints 2x1 plus x2 less than or equal to 50, 2x1 plus 5x2 less than or equal to 100 and 2x1 plus 3x2 less than or equal to 90. So there are three constraints with all inequality as less than or equal to. So we have to add the slack variables in order to eliminate this less than or equal to inequality and to make it as equal. So we write 1 as 1 to our first constraint and 1 as 2 to our second constraint and 1 as 3 to the third constraint. Also these s1, s2, s3 are called slack variables. So after that, since there are three constraints, when we are using 1 as 1, we have to put 0 for the coefficients of s2 and as well as for the coefficient of s3. And here when we are using 1 as a coefficient of s2 in second constraint, means we have to use 0 s1 and 0 s3, and since here we are using 1 s3, we have to put 0 as the coefficient of s1 and s2 in third constraints. Now the number of variables are 5 and they are x1, x2, s1, s2 and s3, and all these are greater than 0. Now we want to find basic variables. So how to find the basic variables? We have to set the number of variables n minus number of constraints 3. So that is n minus m equal to 5 minus 3 equal to 2 variables. So we have to set 2 variables to 0, that is x1 equal to 0 and x2 equal to 0, and we call these x1 equal to 0 and x2 equal to 0 as non-basic variables. When x1 equal to 0 and x2 equal to 0 is used, we will have s1 equal to 50, s2 equal to 100 and s3 equal to 90, which is given here. And we call these three slack variables now as basic variables. Okay, so now we are going to solve this LPP in Excel solver. So how to solve this Excel means we want to write all these are coefficient of basic variables in our objective functions, and all the coefficient of all the variables in the objective function is written here 4, 10, 0, 0, 0. So this 4 is the coefficient of x1, 10 is the coefficient of x2, 0 is the coefficient of s1, 0 is again coefficient of s2 and 0 is again coefficient of s3. And here we are writing the right hand side of our constraints, that is first constraint we are having the right hand side as 50, and for second constraint it is 100 on right hand side, and for third constraint it is 90 on the right hand side. And this is called as Aij, and these values are taken from the constraints coefficients. So 2, 1, 1, 0, 0, 2, 5, 0, 1, 0, 2, 3, 0, 0, 1, and these values are filled here. Okay, now we want to find zj minus cj. How to find this zj minus cj? So here we are using a formula. So in the 7th row we are using formula equal to sum product is equal to sum product of this cb comma this cj. Okay, so we will have 0, and for this from x1 to s3 we want to find this zj minus cj. Yes, summation of cb aij minus cj. So for this xb column we are using summation cb into xb. For this x1, x2 up to s3 we are using zj minus cj equal to summation CBAij minus Ej. So Aij here refers these elements. So here we are having equal to sum product of this CB comma this Aij. Okay, and I want to lock this CB for all the calculations, so I am using dollar symbol to lock this CB value. So now the CB value is locked, only the Aij's will vary. And now I am using minus this Cj row values. Okay, so only the CB values are locked and remaining values will vary according to each row and column. Okay, so here I am having -4. When I drag this up to C3, I will have the remaining Zj minus Cj values. Here we want to find the most negative value. What is the most negative value here? So -10 is the most negative value. So we call this column as pivot column. We call this column as pivot column. So after finding this pivot column, we want to find the ratio. The ratio theta is given by minimum of this xb divided by this Aij. Definitely this Aij should be positive. It should be greater than 0. So we are using the formula here. Here all the values are positive only. So equal to this xb divided by the pivot column element. So we are having 50. Now I am dragging this up to this. So here the least positive value is 20 and it appears in the S2 row. So here we are choosing this. This S2 row, and this is our pivot row. So the intersection of pivot row and pivot column is called pivot element. So 5 is the pivot element here. We want to make this pivot element as 1, and we want to make the elements above and below of this pivot element as 0. So we are doing some calculations here. Since the pivot element appears in S2 row and X2 column, here X2 will enter the basic variable and the S2 will leave the basic variable. Since X2 is used, the coefficient also used here. So the coefficient of X2 is 10. You can also check here. The coefficient of X2 is 10. So that is what we use in CB, that is coefficient of basic variable column. Now we want to divide this entire row by this pivot element. So I am using the formula equal to this element divided by this pivot element. So all these rows should be divided by pivot element. So I am locking this pivot element. So I am using dollar symbol before and after F, since it is appearing in the F column, F and 5. Okay, so this D should not be locked. If I lock D means E cannot be divided. and F cannot be divided, G cannot be divided. So we want to divide everything by same element, means we have to lock the same element. Okay, so now we are having 20 here, and when I drag it up to S3, we will have a new equation, and this new equation is called pivot equation, Okay, now if we want to find the remaining values, we are making a small calculation here. So our aim is to make 0 in S1 x2 and S3 x2. So we are doing a calculation as equal to the element here, that is D4, minus the element in the element, okay, the minus the element in this multiplied with corresponding element of this, corresponding element of the previous table. So I am locking this element because everything should be multiplied by this. I am closing this bracket, and we will have 30 here. So when I drag it, we will have 0 here. So when we have 0 about a pivot element, we can assume that our calculations are right. In the same way we are doing here it is 90, so we are using equal to the previous element minus within the bracket the pivot equation element multiplied with the pivot column element of previous table, and this should be locked, because all the row values should be multiplied by the same 3. So that is why we are locking this variable. So here we are having 30, and now when I drag this, we will have some values, and to ensure that we have proceeded in a right way, we can check whether 0 is below the pivot element. Yes, the 0 is below the pivot element 1. Okay, so now our calculations are right. Okay, now again we want to find this Zj minus Ej. So this Zj minus Ej for xb column is summation cb into exb. So for this we are using once again sum product of this column comma this column. So we will have 200, and for this Aij table and for this Aij rows, we will have Zj minus Ej equal to summation cb Aij minus Ej. That is our formula. So we are using equal to, so cb, what is cb? So again we want to use sum product formula. Here it is sum product formula, sum product of this comma this, and I want to lock this cb, that is this b column should be locked so that it will be used throughout the rows. So it can be locked by putting dollar symbol on both side of b. Okay, now minus Cj value minus so equal to sum product of CB equal sum product of CB comma Aij minus CB Aij minus Cj, and the CB value should be locked. The CB value should be locked by putting dollar symbol on the both side. So we are locking this because we want to use the CB value to get all the values of the row. So we are having 0 here. When I drag it, we will have all the values as 0 and only one value as 2. And only one value is 2. So all the values of Zj minus Cj is positive here. All the values of Zj minus Cj is positive here. So I can write the formula here. So we are having the formula for this XB column. For this XB column, we are having the formula Zj minus Cj. Okay, for XB, we are having Zj minus Cj equal to summation CB into XB. CB into XB, and for Aij column, we are having the formula Zj minus Cj equal to summation of CB into Aij minus Cj. So using this formula only we are calculating this last column values. Okay, using these values only we are calculating these last column values. And now we have found that all Zj minus Cj is having positive value, there are no negative values. So we are having maximum Z equal to 200, and there is no x1 here, so x1 equal to 0, and for x2 we are having the value of x2 as 20, so x2 equal to 20. So these are our solution: maximum z equal to 200, x1 equal to 0, and x2 equal to 20. And now our solution is optimal. I hope this video will definitely beneficial for you all. So this is how we are using Microsoft Excel to solve an LPP by applying simplex method technique. Thank you all once again.